Hello everyone, myself Ajaykumar, Assistant Professor in the Department of Mathematics. Today's session, now I am going to explain another method, the Modified Eulers method. Okay, now in the last two sessions, already all of you know that how to solve the first order and first degree ordinary differential equation by using Taylor series of expansions here. Okay, in the today's session, now you can understand how to solve the first order and first degree ordinary differential equation by using the modified Euler's method. Okay, let us consider the ordinary differential equation is in the form of with the initial condition y of x naught is equal to the y naught. Okay, here now in the last two sessions, now all of you know how to solve the these type of ordinary first order and first degree differential equation by using Taylor series method. Okay, in the today's session, now you can understand how to solve by using the numerical technique by modified Euler's method. Okay, here now first we consider by modified Euler's method, okay, the predictor formula. Okay, here equation 1 be the Euler's predictor formula. First we predict. Okay, now we can consider in terms of Euler's predictor formula. Okay, we can estimate the corresponding yn values at the particular point of x. N is equal to the x naught plus nh. Okay, here h step length, okay, since accuracy is poor in this formula, especially in the first equation, okay, now the Euler later he consider another alternative formula. Okay, that will be the corrector formula. Otherwise, now we can specify in terms of okay, in the corrector formula, yn c is equal to the yn minus 1 plus h by 2 f of xn minus 1 y of n minus 1 plus f of xn yn p. Now that will be the equation 2 here. Okay, is it clear? Now once again we have the differential equation is in the form of the expansion. Okay, now with the initial condition y of x naught is equal to the y naught here. Okay, now we can solve the first order and first degree ordinary differential equation with the help of modified Euler's method. Okay, we can estimate the yn value at the particular point of xn is equal to the x naught plus nh here. Okay, now h be the step length. Now we can consider in terms of h be the step length. Okay, now what about here s? Euler first identify the formula is said to be the predictor formula. Ynp is equal to the yn minus 1 plus h f of xn minus 1 yn minus 1. Okay, now the later he corrected, okay, for the better accurate values, okay, he consider ync is equal to the yn minus 1 plus h by 2 f of xn minus 1 yn minus 1 plus f of xn yn p here. Okay, and next we discuss some examples on the modified Euler's method here. Okay, now the first example, using modified Euler's method, find y of point 2. Here dy by dx is equal to the x plus y, with y of 0 is equal to the 1. Okay, initial conditions are given. Okay, and also h value is given 0.2. Carry out two modifications. Okay, now what about here is, first consider okay, here yes. Now in the first example, here given dy by dx is equal to the x plus y, with initial condition x naught is equal to the 0, y naught is equal to the 1 here. Okay, h is equal to the 0.2. Okay, now x1 can be represented in terms of, Now x naught plus 1 into the h is equal to the x naught 0 plus 1 into the h value 0.2. Now we get x1 is equal to the 0.2 here. Okay, now the question, now we can estimate, okay, we can find out the y of 0.2, okay, that particular point, okay, y of x1 to the value of y we can estimate here. Okay, now we have the Euler's predictor formula. Ynp is equal to the yn minus 1 plus h into the f of xn minus 1 comma y of n minus 1. Okay, if we take n equal to the 1 here, okay, n equal to the 1 means here y1p is equal to the y0 plus h f of x0 comma y0. Okay, y1p is equal to the y0 value 1, h value 0.2 given. Okay, f of x0, okay, x0 value 0, y0 value 1 here. Okay, next y1p, okay, y1p here 1 plus 0.2. Okay, now already we have the function, okay, function is nothing but x plus y here. Now we can specify in terms of, okay, now x in place of x here x0 we can replace, in place of y here y0 we can replace, that's why here 0 plus 1, y1p is equal to the 1.2 here. Okay, now the next one s. Now the since accuracy is too poor in the value of 1.2, okay, that's why here now better accurate values here. Now we can consider in terms of ync is equal to the yn minus 1 plus h by 2. Now f of xn minus 1 comma yn minus 1 plus f of xn comma ynp here. Okay, now if n equal to the 1 here, okay, y1c is equal to the, okay, now the y0 h by 2 f of x0 comma y0 plus, okay, here x1 now we can denote here n value 1 here, the y1 p now we can specify here. Okay, now what about the next one? Now we can specify in terms of the corresponding here. Now we can represent in terms of, okay, here particularly y1c here 1 plus h value 0.2 by 2, f of x0 value 0 comma 1 plus f of x1 value 0.2 comma y1p here 1.2 here. Okay, now using calculator after the simplification we get y1c is equal to the 1.24. Right, now the next one y1c1, okay, y1c1 means here is 1 plus 0.2 by 2, okay, right, f of 0 comma 1, okay, now the plus f of 0.2, okay, 0.2 means here now the x1 value, okay, y1p the in general already all of you know that, okay, here we replace with the y1c the previous corrected value 1.24 here. Okay, after the simplification now we get y1c1 1.244. Now the next one, same similarly now repeatedly we can apply the formula. Now we get the y1c2 is equal to the 1.2, the 444. Okay, now that's why here finally we can conclude that y of 0.2 is equal to the 1.2444 here. Okay, next we discuss the another second example. Okay, next, second example we can consider. Now, using modified Euler's method, find y of point 2. Here, dy by dx is equal to the y minus x by y plus x with y of 0 is equal to the 1 here. Okay, here, now for h here given point 1, carry out two modification. Okay, now given dy by dx, now we can consider in terms of, okay, y minus x, denominator y plus x. Okay, now we can assign the function f of x comma y. Okay, the initial given data, x not equal to the 0, y not equal to the 1, h is equal to the 0.1. Okay, now we can estimate the y1 value. Okay, at the particular point x1 is nothing but x naught plus 1 into the h here. Okay, now n value 1. Okay, now what about here s 0 plus 1 into the 0.1, now we get 0.1. Okay, at the point x1 here, now we can consider in terms of. Okay, now what about the next one? We have the Euler's, the first formula, otherwise we can call in terms of predictor formula. Yn p is equal to the yn minus 1 plus h into the f of xn minus 1 comma yn minus 1 here. Okay, now if n equal to the 1, okay, n value 1 here, now y1p is nothing but y naught plus h into the f of x naught comma y naught here. Okay, right, y naught 1, h value 0.1. Okay, now the apply the function. Okay, here function f of x naught comma y naught available. Okay, here function here y minus x by denominator y plus x available. That's why here y naught minus x naught, denominator y naught plus x naught here. Okay, now substitute the initial data. Now we get y1p is equal to the 1.1 here. Okay, now the next one, the character formula is given by. Okay, now what about the character formula is given by ync yn minus 1 plus h by 2 f of xn minus 1 comma yn minus 1 plus f of xn plus yn p here. Okay, right, if n equal to the 1 here, now what about the changes here? y1c here y naught plus h by 2 f of x naught comma y naught plus f of x1 comma y1 p here. Okay, right, y1c is given by, now y naught value 1 here, h value 0.1 by 2, now f of x naught comma y naught. Okay, f of x naught comma y naught means here 1 minus 0 denominator 1 plus 0 plus, now f of x1 comma y1 p here. Okay, y1 p means here, okay, now what about here x1 value 0.1. Okay, now already we have, now the y1p 1.1, that's why here 1.1 minus 0.1 denominator 1.1 plus 0.1. Okay, using calculator now we can simplify, we get y1c is equal to the 1.0916 here. Okay, here now in the question carry out two modifications. Okay, now that's why here one more time now we can apply the character formula. Already we have y1c. Okay, y1c1 suppose we can replace with the here y1c here. Now we get y1c1. Now using calculator the directly written, now after simplifying 1.0916 here. Okay, now finally the answer for the y of 0.1 1.0916 here. Okay, now the example second one. Okay, next we consider example 3, the answer. Okay, next we consider the example 3 here. Okay, using modified Euler's method, find y of point 1 here dy by dx x minus y square with y of 0 is equal to the 1 here. Okay, now given h value 0.1, carry out two modifications. Okay, now what about your s given dy by dx, now x minus y square. Okay, with initial data x naught is equal to the 0, y naught 1. Now h 0.1, okay, x naught x1 is equal to the x naught plus 1 into the h here. Okay, 0 plus 1 into the 0.1 is equal to the 0.1. Okay, we can estimate the y of 0.1, the value here, that's why here. Now we have Euler's predictor formula. Okay, the predictor formula means here yn p is equal to the yn minus 1 plus h into the f of xn minus 1 comma yn minus 1. Okay, if n equal to the 1, y1 p is equal to the y naught plus h into the f of x naught comma y naught here. Okay, now next one, y1 p is equal to the s1 plus 0.1 f of 0 comma 1. Now using in the simplification, now we get the y1 p is equal to the corresponding here 0.9 here. Okay, now the next one, since accuracy is too poor in the value 0.9, okay, we obtain the better accurate values here. Okay, the Euler's corrector formula is given by ync is equal to the yn minus 1 plus h by 2 f of xn minus 1 comma yn minus 1 plus f of xn comma yn p here. Okay, next one, if n is equal to the 1, okay, now y1c is equal to the s y naught plus h by 2, right, f of x naught comma y naught plus f of x1 comma y1 p here. Okay, now y1c, now substitute the initial data y naught here 1, now we can denote in terms of h value 0.1, denominator 2, okay, f of x naught comma y naught means here, now we can specify in terms of the particularly, okay, for the function form. Okay, now we can assign that will be the particular function f of x comma y here. Okay, right, s 0 minus 1 square plus f of x1 comma y1 p. Okay, x1 means here 0.1, now we can denote, minus, okay, 0.9 whole square, now we can specify here. Okay, now using calculator, now we can find out y1c is equal to the 0.9145 here. Okay, now what about here s? Now we have to find out y1 of c1 in such a way that now here you just replace with the y1p here. Okay, y1c you can replace 0.9145 whole square. Okay, the same procedure. Now we can with the help of calculator simplify. Now we get 0.9132 here. Now one more better accurate value now we can find out s. Okay, once again y1 c1 here, now 0.9132 replace here, rest of the remaining the same expansion. Now we get 0.9133. Finally we can represent y of 0.1 is equal to the 0.9133 here. Okay, now the question here, estimate y of 0.1, okay, with the help of the modified Euler's method. Okay, carry out two modifications. Now we can consider in such a way that y of 0.1 is equal to the 0.9133 here. Okay, the next exam, using modified Euler's method, find y of 0.1 here dy by dx is equal to the 3x plus 1 by 2 of y with y of 0 is equal to the 1. Okay, h value 0.1. Okay, carry out two modifications here. Okay, the answer, Look here. Now the next fourth example. Using modified Euler's method, find y of 0.1 here dy by dx is equal to the 3x plus 1 by 2 of y with y of 0 is equal to the 1 here. Okay, given dy by dx 3x plus 1 by 2 of y. Initial data x0 0, y0 1, h value 0.1 here. Now x1 value x0 plus 1 into the h, 0 plus 1 into the 0.1, we get 0.1. Okay, with the help of Euler's predictor formula, yn p is equal to the yn minus 1 plus h into the f of xn minus 1 comma yn minus 1. Now, if n equal to the 1, y1p is equal to the y0 plus h into the f of x0 comma y0. Now, substitute the initial data as y1p is equal to the 1 plus 0.1 3 into x0 plus y0 by 2. Okay, now the next one, now we can specify in terms of y1p is equal to the 1 plus 0.1 3 into the 0 plus 1 by 2. Okay, using calculator now we can simplify y1p is equal to the 1.05 here. Okay, now we consider Euler's character formula. Ync is equal to the yn minus 1 plus h by 2 f of xn minus 1 comma yn minus 1 plus f of xn yn p here. Okay, now if n equal to the 1 here, y1c is equal to the y0 plus h by 2 f of x0 comma y0 f of x1 comma y1p. Right, substitute the initial data as y1c is equal to the 1 plus h value 0.1 denominator 2. Now the function here 3 into the 0 plus 1 by 2. Okay, the y0 value 1. Now 3 into the 0.1 plus 1.05 denominator 2 here. Okay, using calculator now we can simplify. We get y1c is equal to the 1.06625 here. Okay, similarly in place of y1p here, now replace with the y1c value 1.06625, we get y1c1 1.0667 here. Now what about the next one, y1c2 likewise 1.0667. Okay, finally we can represent y of 0.1 is equal to the 1.0667. Okay. Okay, the example for the fourth one. Thank you for watching the session 3 video.